Today what we're going to learn how to do is to do some gear train calculations. So we have 3 example problems. 2 are very simple, and the third one is going to have multiple reductions. So if we read the first example, it says we have a gear set with 13 teeth on the pinion that is spinning at 11,000 RPM, and there's 47 teeth on the gear. What is the speed of the gear? So we'll have the pinion is going to be the driving mechanism, the driving gear, and that is the smaller gear. So we're going to make sure that that is gear 1, and then the gear 2 is going to be what's receiving the power from the pinion. Now, what we're going to do is we're going to go ahead and assign some variables to the numbers that we have. So I'm going to go ahead and write N1 over the 13. I'm going to write S1 over the speed, and I'm going to write N2 over the 47. And what we need to do is we need to write an equation to figure out what we're looking for. The speed of the gear is going to be S2. So we go ahead and set this up. What we're going to do, I always like to put what I'm looking for in the numerator. So I'm going to have S2, and I'm going to put this over S1. We're basically setting up a set of ratios to help us figure out how the values work out. Now, S2 over S1, speed and number of teeth have an inverse relationship. So that means with my S1 is in the denominator on one side, I'm going to put it in the numerator on the other side. So my S1 here, my N1's on one top in the numerator. And then I'll put N2 over here. Okay? Now I'll go ahead and fill in the information that I have. And S2 is what I'm looking for. I have 11,000 here. And I'm going to go ahead and put 13 over 47. Okay? So what I'll do here is I'll go through the math. I can cross multiply and solve. So cross multiply and solve. I'll have S2 is going to equal 13,000 times 13 times 11,000 all over 47. And what I'm going to get is 3,042.5. Okay, and what I'm going to do is I'm just going to round up to the nearest whole number. So I'll have 3,043 RPM, and that'll be my answer for the first problem. Okay, if I scroll down to the second one, I have a gear set with 7 teeth. That's going to be N1, and the pinion is spinning at 10,000. That is S1. And I have a gear spinning at 4,500, that is S2, and I need to find the number of the teeth on the gear. So I'm solving for N2. So we're going to use the same relationship that we had before, N2 over N1. I always put what I'm looking for in the numerator. That way it's easier for us to solve. And I'm going to put S1 over S2 because there is an inverse relationship. If I substitute the numbers in, I'll have N2 over 7, and then 10,000 over 4,500. If I go through and do my cross multiplication and solving, this is what I'm going to get. N2 equals 10,000 times 7 over 4,500, and I'm going to get 15.55 teeth. Now the problem with that is I cannot have a fraction of a tooth. I have to round up or I have to round down. Now since there's no speed restrictions, I'm going to go ahead and use my regular rounding rule. So I'm going to go ahead and say that I have 16 teeth on that gear there. Now when I do that, I'm going to have to go back and recalculate the speed because the speed will change. Since I've rounded the teeth, the speed is going to change. So I'm going to have to redo another calculation here. I'm going to find S2 because that S2 is no longer going to be 4,500 because I rounded the teeth. So I have to redo this calculation here, again using my relationship. Okay, and I'm going to go over and substitute my numbers. I'll have S2 because I'm looking for the new speed for 2, and I've got 10,000, and then I've got 7 over 16. If I go through and do my cross multiplication, I'll find that my S2 is equal to 4375 RPM. Okay? And then we are finished that problem. Okay? Now the next problem that we have is a little bit more involved. We have a double reduction gear train. We've got lots of information in here. The first gear reduction has 13 teeth on the pinion, 43 teeth on the gear, and that speed is 14,000 RPM. We don't know the torque at this time. Okay, the speed for the gear is on the reduction is unknown as well. The second reduction has a pinion of 17 teeth with a torque of 12 inch-pounds. It is spinning at the same speed as the gear on the first reduction. So those numbers are going to be the same. Okay, the speed is unknown. We don't know how many teeth are in the gear on this reduction, but we want the speed to be approximately 1500. So the first step in this problem is we're going to fill in, we made a chart, and we're going to put the chart in order here. There's a specific way that we're going to make the chart. So we have the gear number, and we're going to go from where the energy starts to where it finishes. And I'm going to use N for my first column, and it's going to be N1, N2, N3, N4, and so on. I'm going to put speed in my second column, and I'm going to put T in my last column. I like to lay this out, that way it's in alphabetical order. That way it's the same every time. So I'll fill in the information that I have to start with, and that is going to be 13 here. I know I'll have 43 here, and I've got 14,000 here. And let's see here, I also have 17 there, and I know I have 12 over here. So those other values I don't have. Now I know that I want it to be approximately 1500 there. So those blank values are missing. Okay, so what we're going to do is we're going to go ahead and start our calculations below. We have a lot of calculations to get those done. Okay, now the first thing that we're going to worry about is we're going to get this speed first. We're going to get that taken care of. So that's the first thing we're going to go after. I'm going to go ahead and set up my relationship S2 over S1. And that's going to equal N1 over N2. Okay, if I substitute my numbers in, I'll have S2 over 14,000, and that's going to be equal to 13 over 43. And you can see that I got that from my chart. If I go ahead and go through my math, my cross multiplication, I'll have S2 is going to equal 4233 RPM. And I can go ahead and write that into my chart. So I'm going to go ahead and write that in a different color. That way you can see that's our answer. So 4233. Now, one thing I do want you to know is that these two gears are on the same shaft. Because they're on the same shaft, they're going to have the same speed and the same torque. So right away, I know that I can fill in some information on this chart. If they have the same speed and the same torque, I know I can write 4233 here, and then I can also write 12 here as well. Okay? So I've got some of the information filled out. Because they're on the same shaft, they have to be spinning together as a unit. Okay? So I'm going to go ahead and draw a line here, and the next set of calculations that I'm going to do, I'm just going to go down my first column. It's always nice to go ahead and get all the first column done first. So what I'll do now is, since I'm looking for N4 in this case, N4 and N3 are working together. So I'll go ahead and put those on one side. And then I'll go ahead and put my S3 and S4 on the other. And remember, number of teeth and speed have an inverse relationship. Okay, so that's why they're reversed on the other side of the equal sign. If I substitute my numbers in, I got N4 over 17, and I've got the 4233 over 1500. That's my approximate speed. And I solve for this. My N4 is going to be 47.97. Now, I cannot have a fraction of a tooth. and I don't have any restrictions on my speed. I just have an approximation for my speed. So I'm going to go ahead and I'm going to round my teeth to 48. Okay, and then I'll go ahead and fill that in on my chart. Okay, that's a little messy. Sorry about that. Now that I have that, I'm going to have to go back and recalculate my speed for my final. So what I'll do is I'm going to cross this out, and I'll have to go back and finalize that. So I have S4 over S3 equals N3 over N4. Substitute my numbers in. S4 over 4233. And then I have 17 over 48. And again, these are just pieces that I'm getting from the chart. The 17 over 48 is here, okay? And that 4233 I already defined. So my S4, if I go through the calculations, you can see that it's going to be slightly different. It's not going to be very much different at all. So I'll go ahead and I'll write that down here. Now the last things that I need to calculate is I need to fill in this torque information in the chart. So I've got a couple more calculations to do and then we'll be all wrapped up. Okay? So I need to find my T4. I'm going to go ahead and I'm just going to start at the bottom and work my way backwards here. So if I start with T4 over T3. Now here's where the difference is. I always like to work with number of teeth and torque directly. Okay? I don't like to work with speed and torque, but you can do either if you like. Number of teeth and torque have a direct relationship. So that means over here, I'm going to write N4 over N3. You can see that the subscripts are not switched. Okay? I'll fill in the information that I have, T4, because I'm looking for that, but there's T3, which is 12. And then I have 48 over 17, and my T4 ends up being 33.9. You always want to take torque to 1 or 2 decimal places. Okay, and then I'll go ahead and I'll write that down in my chart. My very last calculation is going to be T1. So I've got T1 over T2, and that's going to be equal to N1 over N2. Okay, so T1 we don't know. T2 we do know it's 12. And N1 we were given that information, that's 13. And we were also given N2, which is 43. And we go through that calculation, and this is what we find, that our T1 is going to have a value of 3.63. Okay, and then I'll go ahead and I'll write that in my chart, and there we go. And we are finished our calculations.